Chapter 2.3, the product and quotient rules in higher order derivatives, day 4. Today we're going to find the derivatives of secant and cosecant functions. All right? Like yesterday, we're going to rewrite secant in terms of sine and cosine. And that would be 1 over cosine. So if you got the secant of x, it's also the same as saying 1 over cosine of x. And to take the derivative of this, that's a division problem, so we can use the quotient rule. So y prime equals bottom times the derivative of the top, and the derivative of a constant is 0, minus top times the derivative of the bottom, the derivative of cosine is negative sine, all over bottom squared, so cosine squared. All right, cleaning this up a little bit, this falls out because that's 0. We've got a double negative with what's left on top, so that would be a positive sine x. I'm going to split the cosine squared to cosine x times cosine x. Excuse me. Then grouping sine x over cosine x. And then 1 over cosine, we got secant x, tangent of x. So the derivative of secant x is secant x, tangent of x. All right? Let's look at cosecant. All right, again, let's rewrite that in terms of sine and cosine. And this would be 1 over the sine of x. Apply the quotient rule. We got bottom times the derivative of the top. 1's a constant, so the derivative is 0. Minus top times the derivative of the bottom. Derivative of sine is cosine. All over bottom squared, so sine squared of x. Simplifying, again, sine x times 0 is 0, so it falls out. So up top we got negative cosine of x. And again, let's split the sine. Sine x times sine of x. We'll group cosine and sine. We'll group 1 over sine. Y prime is negative cosecant of x, cotangent of x. So in review, the trig functions we've done the last couple days. Derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. And again, I would like to draw the attention to we got tangent is positive, cotangent is negative. Tangent is secant, cotangent is negative cosecant. Okay, and squared on both of those. Coming down to secant, secant x, the derivative is tangent x, secant x. I wrote it as secant x, tangent x on the last page. It's commutative, so you can do it either way. Cosecant is negative cosecant, cotangent. And again, secant is positive, cosecant is negative. Secant is secant and tangent. Cosecant is cosecant and cotangent. All right? Anything that's a co when you take the derivative always ends up negative. Anything that's not a co will end up positive. All right, let's look at a few problems. F of x equals secant x minus square root of 2 tangent of x. All right? Take our derivative, f prime. And I've got the disappearing pin on you. F prime equals the derivative of secant is secant x, tangent x. minus square root of 2 times the tangent of x. Well, the square root of 2 is a constant, so we use the constant multiple rule. The derivative of tangent is secant squared. And multiply that by square root of 2. So f prime is secant x tangent x minus square root of 2 secant squared of x. F of x equals secant x over the quantity 1 plus tangent x. Couple ways we could look at this. Excuse me. The easiest way would be to use the quotient rule. Because we got a division, use the quotient rule. So we'll go f prime of x equals bottom times the derivative of the top. The derivative of secant is secant tangent, so secant x tangent of x, minus the top times the derivative of the bottom, and then we got 1, which is a constant, so that's 0, plus the derivative of tangent, which is secant squared of x, all over 1 plus the tangent of x squared. All right? And for our purposes, that's far enough. You may be able, in some situations, you may want to simplify this. Be secant cubed, distribute a little bit there. But for our purposes, and on the AP exam, if you find the equivalent expression, you're fine without simplifying. And our final problem today should look familiar because we did it in yesterday's video lecture as well. Let's take a look and do this a different way though. Yesterday we converted this to cotangent over sine. Today, now that we know the derivative of cosecant, we can use that. All right? So the derivative of cosecant, is negative cosecant x cotangent x. So we got, I do first, derivative second. I did derivative of the first. So we'll keep the second. So we got second derivative of the first plus first derivative of the second, and derivative of cotangent is negative cosecant squared. If we wanted to clean that up, we could. I'll clean it up just a little bit. So we got a double negative, or two negatives there. Not necessary to factor it out. So we got negative cosecant x cotangent squared x minus cosecant cube of x. Right, so in conclusion, we now know the derivatives of all the trig functions. All right? The derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. The derivative of the tangent of x is secant squared of x. The derivative of cotangent of x is negative cosecant squared of x. And our two from today, the derivative of secant of x is secant x tangent x. And the derivative of cosecant x is negative cosecant x cotangent x.